My lab was on Monday, so the crystals have had about 3.5 days to grow. Looking at the vial, the solution seems to be in the same state that it was walking out of the lab on Monday, clear and no signs of crystal formation yet. This could be due to the fact that only a few days have elapsed and the vial has been jostled a few times by accident, which could have also affected the growth of the crystals. I also placed the vial above the radiator in my room, so the heat from that could have also affected the growth of the crystals. So I plan on moving the crystals to the corner of my desk, away from the radiator, for the rest of my experiment. To make the alum crystals, we synthesized alum from aluminum metal. To do so, we need to go through 4 separate chemical reactions. The first reaction has aluminum dissolved in a solution of 4 molar KOH. Solid impurities will precipitate out of the solution, which can be removed. To the AlOH4- solution, we added 9 molar sulfuric acid. Initially, aluminum hydroxide precipitates out of solution. Additional sulfuric acid neutralizes the basic aluminum hydroxide precipitate, and the solid hydroxide dissolves. An ice bath is used to precipitate crystalline alum from solution finally. However, the crystals obtained from the synthesis will be too small to provide much structural information, so we have to synthesize 1 or more larger crystals by slowly evaporating a saturated solution out of the alum. So our last step was creating the solution. To make the NaCl crystals, you would start by dissolving as much salt in the water as you can. By heating the water during this process, more salt can be dissolved and a supersaturated solution can be made. Then, as the water evaporates, salt crystals precipitate out, creating a nucleation point on which the precipitate grows, ultimately forming a large crystal or multiple crystals on the jar or container that you place your crystal solution in. Another way to make crystals is through the Epsom salt and the cooling method. Start by dissolving the Epsom salt in a cup of warm distilled water, stirring throughout. Once no more Epsom salt can be dissolved, pour the solution into another container, making sure no undissolved salts get into the second container. Then put the bowl in the fridge for about 3 hours, at which point crystals should begin forming. Cooling the solution rapidly encourages fast crystal growth since there is less room for the dissolved salt in the cooler, denser solution. As the solution cools, the magnesium sulfate atoms run into each other and join together in a crystal structure, creating small, thin ice crystals. I got this from thescientificamerican.com in an article titled Home Crystals.